All right, guys, we're going to be starting analyzing some statistics for the next week and a half or so, and we're going to dive back into some skills initially that you should be familiar with from Algebra 1. So things like mean, median, mode, range, those are coming back. But we're also going to learn a new vocabulary term as well, and a new number that we're going to have to find when we're given a bunch of data. So we'll start with this example here. We've got a sample of students' test scores listed below. And it says find the mean average of the scores. So to find the mean, just to remind you, mean is just when you add up it's the sum of all your scores over the number of scores. So we just add up all those scores and we divide it by however many test scores are there. So it looks like we have 18 scores there. So to calculate this mean, we're going to add up 56 plus 68 plus 72. And we're just going to keep adding all these numbers plus 100. And we're going to divide it by 18. Now I'm going to do this on Delta Math. You'll be able to do it on your graphing calculators. We'll talk about how to do that when we all get into class on Monday, and we'll start using the graphing calculators for all this stuff. But for this, I'm going to end up using Desmos. So what I did here is I just took all my numbers and added them all up, and that's all my numerator. And this is nothing new, obviously, but then I just took this and all divided it by 18, and I end up with 83.72 repeating. So the mean average of these scores is 83.7, we're going to say for this case. And we'll say approximately. All right, so the second part of this question says what percent of our scores lie above and below the mean? So we've got a mean, we've got 83.7, which is the average of all of our scores if we add them up and divide by the number of scores. And if I draw that line right here, that's where that line would be, right? My question is, what percent of my scores are below that, and what percent of my scores are above that? That's the question here. So let's just think about that for a second. I've got 1, 2, 3, 4, 5, 6, 7 of my scores that are below the mean. Okay, so that means that if I do 7 out of 18, that should give me the percent of scores, or that should give me the scores that are below the mean. I can turn that into a percent. And then the complement of that, I guess, all the other scores would be the ones that are above the mean, 11 out of 18. So I can do 7 divided by 18 and 11 divided by 18. So it looks like I have 39% and 61%. So 39% are below and 61% are above. Which is a little counterintuitive, right? Because if you have an average, usually you'd assume that half the scores would be above it and half the scores would be below it. That's not always the case because you have outliers and numbers that skew the data a lot. The last thing we're going to do here in this part is calculate the standard deviation of the scores. Now at this point, I'm not actually even going to show you the formula for calculating it because there's not much point to it. We have graphing calculators that'll calculate this for us. We have Desmos that calculates it for us. So what I'm going to ask you to do is put all of that data, all of those numbers, into a table in Desmos. All right, so put them all into X1 in a table. And actually, this is a fast way to calculate anything that's statistical in Desmos. We don't have to go through and add numbers. Like I could find the mean of this by just typing mean and putting in parentheses X1, and it'll tell me there's the mean, right? It just calculated all that for me. So there are fast ways to do this. To calculate the standard deviation, all you have to do is type in STDEV, parentheses, and again, we're going to use X1. So it looks like the standard deviation of this population here is 12.04. We'll say 12. So let's come back to this, and I'll explain why we use that number. So this symbol here is the symbol we use for standard deviation. It's a sigma. I know we used a sigma before that looks like this. They're both called sigma, but they're different types of sigma. I guess you could think of it as being capital letters and lowercase letters. But we're going to refer to this sigma when we talk about standard deviation. All right, so we now have the standard deviation of the scores, which is going to help us kind of separate the data and figure out which ones are close to the mean and which ones are far away from the mean when we get to that point. So what I want you to start doing is think about it as, like, we've got a number line here where the mean goes right in the middle, and this would be your 83.7. And then from there, we've got a bunch of scores that are within one standard deviation in either direction, so -1 sigma or +1 sigma, that are plus 12 from that or minus 12 from that. So this would be plus 12, this would be minus 12, right? And then we could go another standard deviation away from that if I added another 12, and that would be 2 standard deviations away. Or we could go this direction, and that would be -2 standard deviations away, right? So that's minus 12 again. So we could keep going 1 standard deviation further from the mean, and then we're going to start to be able to place our data in here, and we'll say, well, which of these test scores go in this group, which go in this group, which go here, which are way out wide, right? So we'll get into plotting that type of thing, and you'll start to see that most of the data is in one particular region. But until we get to that point, we're going to start using these numbers that we've come up with. So let's use this example that says the track times of 15 runners are listed below. So we got runners running around a track, and these are their times in seconds. It says how many runners are within 1 standard deviation of the mean. So what we're going to have here is, just like in the last example, we're going to have a number line here, and our mean is going to be right there. Well, we've got to find that mean. So let's get out our Desmos graphing calculator. And let's take all of that data we have and put it into the table. Again, your graphing calculators that we're going to use in class have tables that we can put this data into and calculate all this as well. So when we get into class on Monday, we'll do this on the graphing calculators. All right, now that all our data is in the table, we need to calculate how many runners are within 1 standard deviation of the mean. So we got to know a few things. First, we have to know what the mean is. You got to know that, all right? And a lot of the times, you're going to see that a symbol we use for mean is this mu is what it's called, all right? That's a symbol we're going to use often for mean. So the mean of this sample, well, we can figure that out by using our Desmos graphing calculator. I'm just going to type in mean, parentheses, and I'll grab the data from column 1. So 118.3 we'll say. So the mean of this data set is 118.3. So that's what goes right here in the middle. Now we're going to have 1 standard deviation above, and we're going to have a standard deviation below as well. So the next thing we got to know is, what's the standard deviation of this set of data? So the standard deviation can be calculated by just doing STDEV. And again, we'll just grab all the data from column 1, and it looks like it's 38.4. So if I go 38.4 above, so plus 38.4, I'll be 1 standard deviation above. And if I go minus 38.4, I'll be 1 standard deviation below. We're going to figure out how many runners are in this range. So what we need to do is, we need to do 118.3 plus 118.3 plus 38.4, and we also need to do 118.3 minus. All right, so we've got from 79.9 to 156.7. 79.9 to 156.7. So let's figure out how many runners are within this measure. 79.9 looks like it starts here, and 156.7 would be here. So of all of our runners, it looks like there are only 1, 2, 3 that are not in this group. So how many runners are within 1 standard deviation of the mean? Well, a way that I could look at this is, I can see all of my data points here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in here, and then I just have a few that are not, right? So how many are within 1 standard deviation? It looks like there are 12 runners that are within that 1 standard deviation of the mean, because they're inside that range. They all fit in there. How many runners are outside of 2 standard deviations from the mean? So right now this is 1 standard deviation, but I could go up another one if I added another 38.4, and I could go down another one if I subtracted another 38.4. So let's see if there are any runners outside of this range. I can come back here, and I can just add another 38.4 on here, and I get 195.1, and I can take away another 38.4 here, and I get 41.5. All right, so I'm down to 38.5 and 195.1. So over here is 41.5, and over here will be 195.1. Okay, so the dots that I made, I guess, aren't very accurate because I should be taking away that dot. It's in the wrong spot here, right? That dot is the 41. So that 41 should be here. And this dot, I know that we didn't make a perfectly accurate drawing here, but that dot should be out here because that's my 200. So I do have one more dot that I've grabbed by going within 2 standard deviations, but it looks like I still have 2 dots on the outside that are outside of 2 standard deviations. So I'm going to say that I have 2 runners that are outside of 2 standard deviations. All right? So just getting you guys used to reading these graphs and kind of seeing these drawn on this, well, I'm not going to call it anything yet, but we are going to start to have a name for these where we have a mean and we have standard deviations. You don't need to be able to calculate them manually because we have calculators that do that. All right, so you'll have some practice tomorrow. Good luck, guys.